Good morning, everyone. Good afternoon, good evening, depending on where you are. We are excited to be again talking to you, and hopefully, you would be enjoying the next 2 hours of lot of learning and inspirations. So, thank you for joining in as like a quick start and to wake you up, everyone, from the early morning siesta. Let me know which city you are all joining from, and we will quickly get started. We have lineup of guests who would be helping you today, and obviously I would not be skipping any moment to talk to you. So please let us know which city you are all joining from, and we'll quickly get started and we'll understand lots of technical stuff as well as behavioral stuff as we move forward. Accra, Ghana. Thank you, Prince. Thanks for joining. I can read some comments. Seoul, Koryo, Mariachi in a jar. I would comment like so good to be with you, and we hope that we give you the quality you are looking for by investing the time, and you are spending so much time and waking up in odd hours, so we really appreciate it. Bangalore, lot of folks. How is the weather in Bangalore, Malini? Is it too hot? Is it okay? Venetia is from India, Sebastian from Tyrian, Albania, Rajneesh is from Hyderabad, Colombo. Happy to have you all. South Africa, India, Hyderabad. All right, nice. So this time we are streaming it live on LinkedIn also, just so that people would have an easy way to access these streams. And thanks everyone for being here. And please ask questions, and I'll quickly add the team which is here with me. So I have Prasad with us. Then Carl is here. Carl would be taking the next section on identity. And obviously, Parna is here, who is helping us with all the chat support and all the backend information which is required. So, good morning, Parna. Happy to have you all here, and we will quickly get started with the next topic. And keep your questions coming. We would be happy to answer as many questions as we can. And if we can't answer it, then bug on LinkedIn, and we would be happy to answer those questions for you. Thank you, everyone. Let me quickly share my screen, and we will get started from there. Now, this is third week and we are progressing towards the fundamentals track. We are also progressing on the security track, and we are trying to include more people so that you could learn from their experience and get benefited from it. But if you look at your agenda, the last week for both the track, foundational and security, is quite open. We are open for suggestion. So if you have any suggestions for us, which we
Ashish,
could use
if
to
you're
give you
sharing
better,
screen, your
I'm doing it in a
screen.
minute. I'm doing it
Okay.
in a minute. Yeah. So if you are having any suggestions, we would be happy to accommodate that. Any topic which you feel are not comfortable or anything which is not as expected, let us know, and we would try to probably give you the best outcome for the time you are spending with us. Give me a minute. I'm trying to share my screen, and let me know once you all see that. I have added it now. And hopefully everyone should be able to see the screen. Difference between IAM key rotation and S3 key rotation. Yeah, Vinisha will take a note of that. We have encryption topic coming up, so we'll discuss that. And we'll remove all of us from the screen so that you could focus more on the content. And then we will discuss interesting stuff as we move forward. And keep these comments coming up so that we can learn about what you are trying to learn and what are your journey and what your challenges you are facing. And we'll try to help you out in that case. So I hope everyone can see the screen. Let's quickly move forward to the topic, which is week three topic. So for the first 40 minutes, we would be talking about fundamentals. Sorry for the typo here. It is still week two, but it is a week three session. So we are on week three. We will be talking about networking devices. We're trying to build some fundamental things so that everyone, even if you are coming for the first time to IT, you would have sufficient data and sufficient knowledge available to fine tune your journey. So that's what we are trying to do here. Then we will be having Carl as guest, who would talk about his very specific demo on identity management, Very interesting demo. He has presented this demo in our internal meeting, and it was so cool. I thought it is better to include it here too. And then we would have Eric Johnson joining us. Probably some of you already know Eric if you've been into developer community. So he would be helping us in understanding what is a developer advocate's life, or what they would be doing on a day-to-day basis, and what skills and technologies they work with. So maybe if you have aspiration for those type of jobs, you could learn from them and maybe ask some questions to them. So this is what today's session is all about. In terms of the first behavioral topic, sorry, so first fundamental topic, I will talk about physical versus logical addressing. For some of you, it would be very basic. We'll talk about some network devices, switches, and routers specifically, and then we'll talk about some common terminologies like what is a three-way handshake in TCP, what is the difference between TCP and UDP, what is a north-south versus east-west traffic, what is the top of the rack switch. So that is the common thing we will be discussing for today. Now, first thing I want to explain you about the physical address versus logical address. Addresses are required, whatever you do. We all have mobile, our phone number is our address. You have an email address, you may have an Instagram ID, you may have a LinkedIn profile. All of these are addresses. Addresses we use to reach out to someone. Like if you have to call me, you would need my mobile number. If you have to send me a thank you card, that would require my postal address to be available to you. Similarly, in computers also there is a physical versus versus logical addressing available. I'll try to explain things to an example. So consider that you have a mobile. So when you have a mobile, obviously there is a mobile number so that people can reach out to you, and that is your 10-digit number which is given to you. That is your mobile number which is available to you. So that's what we are using here as a mobile number as my logical address. You do not sorry, your mobile service provider will pick it up for you, or you would pick it up from the list of anything which is available, and then this format will be a 10-digit mobile number which you have, and you would have a physical address also with your mobile which is not directly visible to you, but that is used to identify the mobile device on the network. You do not control it. This is called IMEI number, International Mobile Equipment ID, and that is provided to you, or that has been embedded into the device by the service provider or the mobile manufacturer. So whenever they have created the mobile, this IMEI is the physical number, and this one is a logical number. Again, one more example to explain these things. We all have our own fingerprints, right? So this fingerprints, we do not select it, and this is manufactured in us. Is when the time when you were came into this world, from that time your fingerprints are there. So that fingerprint is IMEI number, you could think of. And then you would have been chosen a name, maybe parents have chosen for you, or maybe later you change your name. So that is a logical name which you have created for yourself. You may still change this, but this cannot be changed. So that is the same concept which applies into TCP IP addresses also. Let's go ahead and talk about that. So IP addresses, when we are talking to a computer, we use IP addresses to communicate to it. V means the programs use a mechanism to communicate. These are considered as a logical address because they are assigned when needed, mostly assigned by a service called DSCP, Dynamic Host Configuration Protocol. In case you need to manually assign it, that is also possible, but very rarely you will do it because it will create a lot of operational overhead. And then what we have here, we have format, and then we have format of 32-bit and 128-bit IP addresses. So these are all the valid options which you could use for creating a IP address. On the other hand, there is a MAC address on every device. So every network device, whoever, this is very specific to Ethernet network. So even if you are on a Wi-Fi, there is a MAC address associated that is called media access control. It's a physical address for you, and it is assigned by the device manufacturer, by which that will be identifying the device, and it could be into 48-bit format or a 64-bit format. Now you may be thinking why I am talking about this, because when the decision of forwarding packet happens, either it would be happening based on an IP address, or it would be happening based on a MAC address. We'll discuss that in technical detail. IP addresses are used by your routers to forward the traffic, whereas MAC addresses are used by your switches to forward the traffic. So we'll discuss both topics and discuss how it actually works. I hope everyone is clear. Now, sometimes people think that what is a network device actually? Why we need network devices? So I will give you an analogy so that you could relate to it. When we are sending our data, we always talk in terms of bandwidth. Think of your bandwidth like a pipe. The bigger the bandwidth, more data will be transferred. The bigger the pipe, more water would be flowing in that. So that is what we mean by having a bandwidth, means a very big pipe on which we can flood a lot of water. And when this water is flowing, I don't expect that all the pipe will be one in straight line. You may need some devices. Maybe you would need pumps, maybe need valves, maybe need fitting, maybe need taps, and these are basically representing your network devices who are transferring your maybe water from one level to another level, or stopping it or forwarding it somewhere. And whatever is flowing inside these pipe, that packets are your like water. So hopefully this has given you some idea like what network devices are doing. Example, same example, if I expand it further onto the roads, think of your bandwidth is like number of lane. More number of lanes available, you would have more traffic going from it. That's true. And when we have network devices, they are basically like here it is a on ramp. Maybe there is a traffic signal, maybe there is a map available by which you decide where to go, and whoever is traveling on this road, those are your packet. So this is exactly what a network is also all about. So we have network devices who help us in my creating traffic in such a manner, or adding traffic in such a manner so that it is able to talk to various deployment or various resources. So that is some analogies to get started with. Now let's focus on the core concept of how this network devices actually work. I'm sure everyone knows about OSI model. I would focus right now on the aspect of different network devices on this OSI model. So if you look here on the physical layer of our network, we would have network cards. This could be a different type of card. It could be an Ethernet card. It could be fiber optics or something else. But network card will actually take your data signals and convert into a format which can be sent over the wire. Even if it is a Wi-Fi, it is still a medium which we are using. And on above layer of that we call data link layer, we have our network switches who are helping us in forwarding the traffic. Just one layer above it, there is a network which is allowing us to route traffic. So that is a network layer is where routing happens. And then you may also have some physical firewall devices within your environment, and those firewall devices may be covering layers from network up to application or up to this point. So it depends, but these are the commonly used physical devices on your environment. Now, routers, if you want, they can be implemented through software. Firewalls, they can also be implemented through software. But switch and network card, these has to be the physical devices by which your data transfer would be happening. So we will be focusing on some of these concepts as we move forward. All right. Anyone, any questions so far? Any doubts, any confusions, anything which is not clear? Let me know here. So these are all your network devices. And when we talk about that, how the network traffic is identified in these location in these devices. So for identification purposes, switch uses MAC address, the physical address we talked about, and your router use IP addresses, whereas your firewall may be talking in terms of packets, and that is header and payload through which you are able to identify the different type of packet, allow or deny them. That's what we could use. Pramod has a question. Any example of router implementation through software? Think of it anything like if in Windows machines, like if it is a Linux machine, you could configure things there, which is a routing software available for that. So you could use some routing software on that. If it is a Windows server you are using, in Windows there is a routing service available that you could enable for it. So those operating system would have their own options available, so you could utilize these type of things. Or if you are looking for, you may think of check for on internet, which is what we refer as a router on a stick. This is basically a USB drive program. You install that in a USB drive, it will boot automatically. It would allow you to connect and perform your routing configuration from that. So software router are implemented by creating network interfaces, connecting to them, and then defining a routing table by which your routers will be making the decision. So software router is implemented. And if I'm talking about AWS, in that when you are setting up a routing table, that is in a way a software based router which you are creating. On top of it, when you are adding a transit gateway, that is again a kind of a software router which you are creating. So that will depend from operating system and vendor to vendor, but idea is it is a computer, and on that a software is running who could listen for various traffic which is coming up and then forward it to the destination of your choice. That's how it would be working. So I hope that answers your question, Pramod. Let's keep moving forward. Okay, so we are now focusing on switches. Switches, you may find switches mostly depicted like this. Or if it is an enterprise solution, then probably switches like this would be there. So switch, it is a a network switch forward data between connected devices. What is going to happen here? So this is port number 1 of my switch. This is port number 8 of my switch. I may have a server here. I may have a client connected here. And when they want to communicate, A will be forwarding packets and it will be received by B depending on some mechanism. We will discuss that. But idea is this is where we would be connecting our network devices. This is used to transfer data between device to device, not between network to network. We would have devices connected, and those devices would be able to communicate through the network switches we have, right? And one switch may have a limit of, let's say, 8 port, 16 port, 24 port, 32 port. It is possible that I am looking for a bigger network. So what I could start doing, I could start connecting my switches in a format like something like this is what one method would be. This is sometimes we refer as a daisy chaining mechanism. So we connect one switch to another, another switch to another, another switch to another. And if let's say it was 32 port switch, so now I have 32, 32, 32 four times. And for that, these additional ports which are there, like if you see port number 25 and 26, those are referred as uplink port, which allows me to connect to other switches. This is one design. But in this design, challenges, let's say if this network breaks in between, then my network will become isolated. So another approach we could follow is a hierarchical design. So you may have your network switches like this, and you would connect it to a core switch, which is a bigger switch and on which all the communication would be happening. So this is another way of connecting these switches so that you could expand your network, but physical communication would always be happening through the network switches. Okay, I hope everyone is following along. When I'm talking about data centers, in data centers we use something called TOR switches, top of the rack switches. So TOR, top of the rack, as the name says, there would be a switch at the top of this particular rack, and it would take care of all the communication. I do not need to have switching software or setting into each of my server. All of my server through the back panel or through cabling will be connecting to my top of the rack switch. And similarly, I may not have only one rack, multiple racks will be there, and these all top of the rack switches probably will be connecting to one core switch, which will be bigger in bandwidth, bigger in performance, and bigger into high availability. So that is what top of the rack switch is. On the top of the rack there is a switch, and it will take care of all the communication originating from that particular rack. All right, I hope everyone is following along. If there is any questions, let me know. I would be happy to answer it. Another common differentiations we have is managed versus unmanaged switches. I would say if you are in enterprises, you will probably not be looking for, sorry, we will not be looking for unmanaged switches. You would probably look for a managed switch. Functionality is same, but managed switch have a specific type of chips in them, which is called ASIC chip, and they would have some software to control it. Whereas unmanaged chips or unmanaged switches, they are just forwarding data without having any software operating system running inside them. A switch, in a way, is a form of a computer. It is not having all the options to connect a monitor or a USB cable, but in a nutshell, it is still having its processor. It still have its memory by which it forwards the traffic. It may have a operating system also, but it is a highly customized fine tuned operating system and logic which is built into it. So most of the time in enterprises you would be looking for managed switches, and they allow you to think to perform things like you can set up duplex on that, you could set up VLANs on them, you could configure port forwarding type of stuff. So lots and lots of things can happen with your managed switches. Companies who are operating in this space, there are many. Cisco is also one known name, which you may find that a lot of people go for Cisco certification. So in that they study about networks options, network switches about Cisco. All right, so that is a switch. How a switch actually works, let's go ahead and talk about it. Let's consider this is my switch here. This switch has 4 ports, and then these machines are connected. Now as soon as these machines start, the default information is the default mechanism is whenever these machines start, they start sending some broadcast, like they are announcing themselves. Like you go into a room and you introduce everyone to you introduce yourself to everyone and saying, hey, I am Ashish and I work in that and that technology. This is what my passion is, this is my interest. So that information is being broadcasted as soon as the device is powered on the network. As soon as the power on happens, it would send some broadcast which is like addressing to everyone, announcing in a way hello world to all the things. As soon as this broadcast happen, there would be a MAC address of that device on the packet which is received, which receives it, and in its table it maintains that okay, on port number 1 we have a device who is ending with 2231. So its a MAC address is maintained within this table. This table is maintained by switches, which is called CAM table, content addressable memory table. So it now knows port 1 is connected to 2231, port 2 again got a broadcast 9945, port 3 and then 0CC9, something like that. Now let's consider here that we have a device D and this device has just joined, or if it has not started any communication so far. So switch doesn't know about it. So this port 4 entry is blank into the CAM table. Now let's say A say, hey, I want to talk to someone, which is D. So he sends a packet. That information comes to switch, but switch doesn't know who is D. So what it has to do, it would then say, can anyone tell me who is computer D? And when it will talk to D, D will say, hey, I am computer D, and that is my MAC address is, let's say, at the end 0814. So now switch knows about it, and then 0814 is recorded into the table, and that's how it populates its CAM table. So as soon as you start a switch, maybe in few seconds it would be able to capture the available ports connected, what MAC addresses are available on that, and through that you would be able to capture the information, right? So this is how CAM table gets started. Is CAM table similar to route table in AWS? In a way, yes, Jaideep, but the way of decision making is different. CAM table exists within the memory of one switch only, right? So if you have multiple switches, let's say switch 1, switch 2, switch 3, switch 4, and they are all connected, the CAM table is not shared across them. So what would happen here? So let's say this switch would have that on my port number 5, I have 15 MAC addresses. This will say on my port number 4, I have 12 MAC addresses. So a switch would learn about all the MAC addresses which are on the other switch, but the CAM table is maintained internally. There is no mechanism of centralizing a CAM table. Option is same, it is still used for forwarding the data, but this time the forwarding decision is done through your network physical addresses, not through virtual addresses like IP addresses. So yes, it is in a way similar to switch, but on a data link layer. Question from Karthik. Quick question. TOR doesn't have redundant power supply. Karthik, it would have 99%. If it is a very customized hardware you have created, then it may not have. But obviously, in a rack, we may not be looking for only one power supply. We would obviously have multiple redundant power supply in those. Again, mostly depends, but it would always be looking for multiple supplies on that. All right. Good. Sab has a question. If Swift broadcast to find unknown MAC address, how does it work? It just says to everyone, it says, hey, tell me who is connected. So when it doesn't know who is all connected, he himself goes and says, like, you come into a room and you do not know the people who are present there, you go to each of them and say, hey, can you tell me who you are? And then I am starting building my network. So I know Ashish is here, I know Carl is here, Parna is here, Prasad is here. So now I know maintain that information into my table, that now these four people are present. So if switch doesn't know who is connected, let's say the switch is just started or it failed, its power supply lost, it power supply come up again. So now it would start with the learning process. So he itself will send a broadcast and will say, hey, who all is connected, tell me your detail. And that's how switch would be getting information. So hopefully SAP that gives the answer. So you are able to get a broadcast done, and through that broadcast switch would learn about who is there. If it is unknown MAC address, let's say you a switch receives a packet for a MAC address 8156 and it doesn't know, it will drop that packet and say, sorry, I don't know who is 8156, this person doesn't live here, and no packet will be forwarded to it. So that's how it would be learning. Okay, so hopefully this thing is clear on switch. Next topic on switch, which is commonly used even into your AWS world, is about VLAN. You do not directly create VLAN, but there is a way when you are using direct connect, that time you would use VLAN. Let's see what we are trying to do here. So switches probably would be connected to a router like we are showing here. So these all switches are connected to router. When I am just making a communication, let's say from A to B or C or D or E or F or GH, probably I would not be needing any router. But router would be used if I am trying to talk to another network altogether. When I am talking to the same network, router may not be needed in this particular case, right? So what is going to happen here? As soon as a request is received, then let's say this person is doing here a broadcast. So if this broadcast is happening, this is traveling to, let me write down things here like this also. So this is all connected here. This is connected and this is connected. Consider you are in a room which is having a huge number of people in that. And there is no partition and you shout from here. So when you shout, everyone would listen to you. We don't want that. So like in offices, instead of a big floor on which everyone is sitting, maybe there would be isolation created for a meeting room, maybe there would be a training room, maybe there would be a cafeteria, maybe there is a block for developers to work, maybe there is a block for software engineers to work. So what we did here, we took a bigger room and broken it down into, let's say, a training room. This is my meeting room, this is my cafeteria, this is block number 1, and this is block number 2. Idea is, now if somebody shouts in block number 2, that message would only be going into block 2, it won't be affecting block 1 or training room. Somebody shouting in a meeting room on a very heated meeting, it won't affect training happening here, it won't affect the area which you have in that other side. So that is how you would be utilizing this type of architecture, where you have broken down your bigger piece of network into smaller pieces. Same thing we can do in our environment like this. So what we could do on switches, on these managed switches, we could create a VLAN. So we could create a VLAN to host our application server. Physically, one application server is on switch 1, another application server is on switch 2, but they would think they are logically connected into the same network. So they would be still seeing both the network information. They would be treating, think like they are now connected to a switch which is for application only. So A1 is connected here, A2 is connected here. Physically they may be across multiple switches, but they are logically being seen as your application VLAN. So application VLAN is a logical isolation. That's how we are able to create a separation between the whole network and keep traffic only within that network. So that is my application VLAN. Same way, we could have created architectures where we have database VLAN, and in that VLAN again physical networks are spread across, but they still seem to be connected to a VLAN database and maybe another web server VLAN which we have. In AWS world, if you have thought about subnets, Those is what is being represented here as a VLAN. So VLAN is a logical construct which is keeping similar type of devices connected together. That is also we do into subnet, and that's how we are utilizing that. You switch broadcast to find unknown MAC address. How does it work? It can't broadcast for unknown MAC address directly. So when it receives a packet, it will check in its KM table that if there is an address available with that or not. If it is not, then it will do broadcast. And if nobody respond on that MAC address, it would say, sorry, this person doesn't live here and I can't forward traffic to there. So that's how we will utilize it. Is there a difference between a MAC address table and a CAM table? Answer for that is no. MAC address table is same as CAM table, but what may happen that if your operating system has multiple network card, it may maintain its own MAC address table. CAM tables are very specific to switches. It is just a way to say the things. MAC address table is more convenient to say, whereas CAM table are very switch specific terminology. VLANs are purely virtual port, or we have to assign any port on switch as well. It depends. Majestic Marku. It depends. Some switches can be giving you option that you could say, hey, I have this application VLAN, and anyone with the MAC address 123.456.789, when they are connected, they should all be part of application VLAN. So now I have laptop server here who is connected here. I move this server and I connect it to a next switch port. It detects the MAC address and assign membership of VLAN based on the MAC address. So that is one option. So who should be part of my application VLAN? I could decide based on the MAC number. Or I could say in switch number 1, port number 1, port number 2, or in switch 2, port 2, in switch 3, port 5, you belong to VLAN. So membership of VLAN can be based on either a MAC address or it could be based on the physical port addresses, right? So it depends. Hopefully this thing is clear. How to create VLAN? Who creates VLAN? Network admins will be creating. VLANs will be created based on the software available. So if it is a Cisco related Cisco hardware or network you are using, then there would be different commands available. And for HP or other Juniper switches, there would be different command available. So your network admin would be creating VLANs for you. Okay. Now let's talk a little bit on the routers. Router are little more smart devices. Router is a device which make communication possible between different network. So we created a network of switches. Switches were able to talk to each other. But what if now this is my application network, this is my database network, this is my uh, uh, web server network, different IP addresses, and now I want to communicate between them. And for this, I would be utilizing a routing device. So router is the device which makes communication possible between different networks. That's what we use router for. Routers are again a special type of computer in which hardware and software are fine-tuned for making routing decision. It also has a way to learn the networks which are connected. So if this router is connected to two networks, it's a 172.16 series, it has 10 series network, it would detect that network which are connected and would build its routing table. And let's say this is interface 1, this is my interface 2. So in its routing table, it will maintain I can go to 172 through interface 1 and I can go to 10 through interface 2. So router would learn about the connected network as we are utilizing here. Right. Right. So hopefully this thing is clear. So routing is the process of moving packet from one network to another, and routing involves two basic activity. First is determine the path, and second forward packets to this path. I use an analogy for router. Let's say you are into a location, and let's say now you want to go to port B. So you would use some software which is like Google Map or maybe another mapping services and put destination, and it will show you the path which is required to go from here. So go here, 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 and then you will reach to B. So that is what a router would be helping you in doing. And it will do two things. It will help you to identify what is the best path, and still you have to go on that path. So I put a destination of airport on my map. I could now go to airport, but I still have to drive, and that's what we mean by forwarding. So router first determines what is the best way to reach to that destination, and then it forward that information to the devices, so that those devices will be using that path to send packet to a destination. So that is the use case of a router. Routers would be making decision based on the IP addresses. They would learn about IP addresses of connected network. Or if a router is like this, let's say this is my router 1, this is my router 2, this is my router 3, then R1 only knows about this network and this network. It doesn't know about this network. So we have to add entry into routing table so that we would be able to send packet to those destination if the need be. Right. Right. So I hope this thing is clear. VLANs are purely virtual port, or we have to assign port. We discuss about that. Does essay technical interview go into details of switches and router implementation? I don't expect that. I don't expect them to ask you routing related question, but it is a good understanding of how communication actually happens. But essay depends. Maybe if you are into a network essay or maybe into a communication essay role, then probably you need to understand it. But this forms all the concept even for VPC. So VPC is also doing the same thing. VPC is helping you to create VLAN, which is subnet. It is helping you to create route table, which is or routing loops or routing, which is route table, and it is allowing you to create firewall, which is basically your the security group and network ACL. So yes, that is how it works. So this is what a router is. Now router are by default chatty. Router are not a person who would not speak up to others. Router exchange information. So if I have connected multiple routers together, let's say router 1, router 2, router 3, router 4, these are all connected. What they would start doing, they would start exchanging information. Consider like you are into a social gathering and you go to a different people and introduce yourself. Hey, I am Ashish. I am a technical trainer by profession and I do XYZ things and I have these hobbies. So same way, all the routers would start talking to each other and exchange information. Obviously security can be implemented on that, who I talk to, but these router exchange information so that I know about it, right? So let's consider that. So let's say you are in a meeting and then three persons are there. This person is doctor, this person is in IT, and this person is, let's say, into life insurance, right? So when these three meet, what they now know, doctor now knows that okay, if I need to talk to someone on IT, I know this person whom I can refer for any IT related job. If this doctor needs life insurance, he could talk to this person, and if this life insurance person needs a IT help or it needs a medical help, now he knows. So that's how they build their network and they exchange information so that everyone becomes aware about what all networks are available, and that is called router convergence. So when you are starting a network, it may take little time to converge the network. Routers exchange information, and by that they know what all destinations are available and how I can go from one destination to another destination. That is called routing protocol, right? So routing protocol are various, whereas what we mostly refer is a dynamic routing protocol, which automatically compels router to exchange information. And in that there is an interior gateway protocol, there is an exterior gateway protocol, means router talking to external world. And most of the time in AWS world, when you are creating a direct connect or when you are sending a VPN connection, you may leverage BGP protocol for that routing information exchange. So BGP is most commonly used over internet, but if it is a private network you are creating, probably you may have used any of these network protocol. OSPF is a very common one for internal network, whereas BGP is a very common protocol to be used for external network. So I hope this thing is clear and you have a better idea on what all these routing protocols are. Okay. How does router know the IP address of other router? Is there a separate table between the router? Yes, SAP. So every router would maintain its routing table and they would maintain entry for it. So they would router table 1, router table 2. They would be having entries, and then like the example I gave you, that doctor now knows who is the life insurance person, doctor now knows who is the IT person, and vice versa. So that is how the tables are maintained between those devices. Okay. Now let's talk about some terminology. I know we are hitting the 40 minutes mark. So let's talk about very common terminologies first. The one common term you will hear when we talk to data center people is north south versus east west traffic. Right. What we see things here, see, this is what my typical data center would look like. I would have these servers or these racks which are there. These will be probably your top of the rack switches you are having here. This is my top of the rack switches, just an example you are seeing. And now I may have a physical or virtual machine here that may be talking to another virtual machine or a physical machine. So that type of communication, when between machines the communication is happening, that is referred as east-west traffic. So east-west traffic, I would say it contributes to around 80% of all the traffic in the data center. That is how most of the time 80% of the traffic is utilized for east-west communication. And when your web server is making communication to external world or external people are trying to talk to your application, that is considered as a north-south traffic, or this one is considered to be less than 20% in a data center. Most of it is considered to be 80% or higher. Right? So how it works? Majestics has a question. There are Cisco protocol and how it is related to AWS. BGP is not a Cisco protocol. No, BGP is not a Cisco protocol. BGP is open standard. So most devices on internet would speak BGP. On the other hand, some protocol may be very specific. But let's say if I'm talking about RIP or RIP or ISIS or other type of protocol, they are vendor neutral. Cisco would implement those protocol in their routers, but it has nothing to do with Cisco proprietary. Cisco has its own proprietary protocol like EIGRP, but BGP is an open standard. Right. So I hope this thing is clear. So this is not a BGP discussion, Kishan, so I can't go into that detail, but probably if it is a lot of interest, maybe we'll consider that other time, but we have limited time here. So this is north, east, north, south, and east, west traffic, which we have here. When we implement TCP IP, TCP IP is a practical implementation, whereas OSI is a theoretical implementation. And TCP IP, though we call it just two protocol, TCP and IP, behind the scene, there are a lot of protocols who are making up a TCP IP. So like when I say a company's name is Larson and Turbo, maybe I say Hewlett and Packard. That doesn't mean that only those two people, Hewlett and Packard, work in that company. There are more people working there. Similarly, when I say TCP/IP, these two are the most prominent protocol of that stack, but there are more protocols working, and they take care of different aspect of their communication. Like here we have ARP, we have UDP, TCP, then we have TFTP, and all type of protocol. So that is all depends on that. So all the distributed system east-west traffic, Anjana, most of the time, yes, unless they are trying to talk to external bodies, that time it would be all east-west traffic which is being utilized in that environment. Right. So I hope this thing is clear. Where can I see the slides again? We will be sending it on BESA website, Sugandha, and probably somebody from the group can give you the link. There is a resource section, that is where you will find all these things. When TCP and UDP communicate, I will take 2 more minutes and then we'll take a break. So TCP and UDP, when they communicate, they have a different mechanism. TCP focuses on building the connection first, whereas UDP is a connectionless protocol, what we call. TCP is sending someone a signed for letter, or if you are from India, we call it a registered letter. Registered letter will only be given to the person who is addressed on it. They have to sign for it and say, I received it, and then only it will be given to you. Whereas UDP is sending someone a postcard. It is best effort. We postal department would not discard your postcard, but it would not be guaranteed delivery. They would still try to send your postcard using the mechanism, but you can't track it. It is not tracked, and we hope it would reach. But TCP works on creating a, like when you have a read receipt on your WhatsApp, that is a TCP kind of communication. When you send someone to an email, they haven't acknowledged it, that is a UDP communication. So it depends. So TCP communication is common. UDP also exists for some use cases, like when DSCP server is starting up, or maybe when DNS server is resolving, they may use UDP as a service for them. So TCP builds connection, UDP is connectionless. TCP uses a sequence number, whereas UDP is a best effort delivery of it. So reliable and unreliable kind of thing, which is going to happen here, right? So if I'm transferring my money from HDFC to IDBI Bank, the protocol is going to transfer packet from HDFC. It would be TCP. it would be TCP, because it is a connection oriented and it's not that easy. There is more things behind than Kishan. It is not just abstracted away in TCP. There would be more higher level protocol. So probably that all transaction will be happening through your HTTP, which is using behind the scene TCP for communication. So these higher level protocol, they use this TCP or UDP. So when a DSCP or a DNS is working, DNS can use UDP for some situation, DNS will use TCP for some situation. Whereas HTTP always uses TCP, whereas my boot P uses UDP protocol. So it depends. A higher level application protocol would use a lower layer UDP or TCP traffic to communicate with. So I hope this thing is clear. I could not complete all the slide, but I would make them available into the BESA web page. So you should be able to get all information there, that what is a three-way handshake, and then how your windowing work when I use TCP, when I use UDP, and what are the port numbers. So that is all will be there into the web page. And if you have any questions afterward, put them into chat, or maybe you could put them into reach out to us on LinkedIn, and we would be happy to answer those questions for you. Shouldn't be a problem. So I would stop here, otherwise I would keep on speaking for the whole day. So let me put a 5-minute timer, and then once we return, we will go into the security track, and Carl will help us with security track. I hope everyone has enjoyed. Give us 5 minutes so that we can also catch some breath and have some water or tea and come back to you. So we will start again in 5 minutes. Thank you, everyone. Talk to you soon. Welcome back, everyone. I hope everyone is back. If you are back, type in chat what is your favorite e learning portal where you learn lot of stuff, where you go to learn things about technology or maybe self help or something else. All right. I hope I am Udemy and Coursera. Yeah, that makes sense. So that is good. Thank you. YouTube. All right, good. YouTube is also a really a useful portal, but I hate that uh, algorithm which tricks me into watching funny cat videos when I'm exploring technical things. So that always happens. So nowadays, Kiku, okay, looks like you are internal people. Thank you. Learn one. I haven't checked that question, so I'll check that. Thanks everyone. So this also gives us idea like what all the resources you are using, and hopefully we would be able to give you similar type of content as it is available. But now let me add Carl to the screen. Carl is one of our technical instructor working in AWS US office, sorry UK office, and Carl and I we both work in the same team. Carl, let me add you here, and now
Okie
hopefully
dokie.
you are visible. Thanks for joining, Carl. Saturday morning. Thank you
No
so
worries,
much.
Ashish.
And Carl is one of our top instructor who is so good with technology as well as implementation of technology for delivering virtual training. He has set up of virtual training delivery with different tools and microphone camera setting is what we always look forward when we have to learn something about virtual streaming. So happy to have you, Carl. I'll quickly talk about what Carl is going to cover so that you all know what is expected, and then we will be uh, handing it over to Carl. Give me a minute. I will share my screen again so that you could see what is expected for today's session. I hope everyone's screen is coming up now. My laptop is a little slow today. Give me a minute. Yep, that is coming up. So we are focusing on security track. Sorry, give me one moment, please. It just went out. So we are on security track. This is week 3 of security track, and we discussed about identity last time, and now we are on protect. And in protect, a very common interesting fact we need is about identity center. So Carl would walk us through a common use case which you will see in current AWS scenario. Most enterprises would be doing this. I don't expect them to use IAM for logging in and performing their task. They would be using a better mechanism than that, and that's what Carl will be all talking about. So Carl, if you want to share something, let us know. I think you
Awesome.
will be using on the
Yeah.
camera itself, right? Camera
Yes.
screen. Yeah, we could see
If you
that.
can just make it full screen, Ashish, that would be
Sure,
great.
I'll do that.
Awesome.
Give
Okay.
me a minute.
So let me just see when it's full screen. I think currently it's a little bit small.
It should be there in a minute.
Okay. Awesome. Okay. So good day to everybody. What I'm going to be doing is to give you a demo of Identity Center in AWS. Now, this is something that used to be called Single Sign-On or SSO. They now call it, I think more appropriately, probably Identity Center. So that's the new name for it. This demo is going to be it's quite a lot of things to go through. So what I'm going to do is I'm not going to be focusing too much on the questions. I'm not sure I can do it in 40 minutes. What I will be doing is at the end, if there's any time left at all, I'd be happy to take your questions. What I'm going to do now is I'm just going to start by explaining to you some of the fundamental things that you want to really understand that are the building blocks of how we make all of this work. And the most fundamental building block of all the building blocks that you're going to have to understand for Identity Center is a thing called a role. Now, in AWS, everybody's heard of a role. If you go into your console like this, go Identity and Access Management, there's the Identity and Access Management service. And then if you want to use roles, you'll see that it's right there underneath users. So if I click on roles, that is where you can go and create roles in your account. Now, what exactly is a role? Now, usually when we present that in a training course or something, we typically draw a picture of it. Even in some of our documentation, please forgive my drawing skills. We draw it as a hat. Okay, we draw it as a hat. Now that is not. It's not like a. I can't draw that hard hat. Like what you would work on a construction site, for example, what you would wear. But just believe me, that over there is a hat, and this represents a role. Whenever you look at AWS and it's visually represented, they show it as a hat. Okay, so what exactly is it that a role is? And I'm going to give you a metaphor first, and then I'm going to give you a practical example while I'm actually creating a role inside of my account. So here's the metaphor. A role, first of all, is a credential, very much like a user is a credential, right? So if I go and create a user in AWS, they will have permanent credentials. When I create a role, that would be a temporary credential. So let's do a little metaphor on an example of how you can use these temporary credentials. Imagine you work in a company. The company has a building. You need to get into that building, and you're going to have an access card. And that access card will open doors in that building for you. Not every door, but you can get into the main building, into the reception area. You can go and work on, let's say you're on the 7th floor. They'll get you into the lift or the elevator, depending on what part of the world you're from. You can get to your desk, and now you can sit there and do your job. Let's say you're a test engineer. I used to do that, used to be a tester. Now, as a test engineer, with your access card, you should be able to get into certain parts of that building on that floor. Go to the reception area, you can go to the canteen, you can go to the restroom, you can go to some of the meeting rooms, you can go to some of the labs, but you can't go absolutely everywhere. Some doors won't open. Right. Now, let's assume that you now go on a fire marshal training course and become a fire marshal. So now you are going to be able to, when there's a fire drill, put on the hard hat, put on the high visibility jacket. And let's assume for the sake of the metaphor that you're quickly going to run to a little reception area on the floor that you're at, and then they're going to issue you with a special new tag and a little access card that's going to be able to, represent this role of fire marshal that you are assuming. And you're now going to be able to use that other tag as opposed to your normal tag that you used to get into the building, to go and check that there's nobody on any of the meeting rooms or anything in that floor. You'll be able to open up all the doors to check that nobody's going to die of smoke inhalation. Okay. So now when the fire drill is over, your credentials will be expired. So you can't use that tag to open doors anymore. You go back to your desk, you take off your hat, you take off your jacket, and now you're just a normal, let's say, test engineer. So that's effectively what a role is. It is something that you assume. You have temporary credentials that you get, and it expires after a certain amount of time. And not anybody can just assume a role. Okay. In order to be able to assume this role of fire marshal, you need to have gone on fire marshal training. They need to be able to identify you at the little desk where you go and say, please give me this new badge. Okay, so they recognize, yes, you've been on the fire marshal training course. Yes, we know you're a fire marshal. There you go. You're allowed to assume this role. There's your tag. Go and clear the floor. So that's basically what a role is at a very high level. One thing I want to just point out is that this metaphor of mine about roles kind of breaks down just a little bit because it's predicated on the assumption that a role can only be assumed by a carbon-based life form. In other words, a person. Okay. A role can be assumed by an internet-connected toaster. It doesn't have to be a person that assumes the role. Okay, so any principle in AWS, whether it's an AWS account, whether it's another AWS user, whether it's another role, whether it's an AWS service, all kinds of things can assume a role. It doesn't have to be just a AWS user that can assume a role. So that's basically the idea behind the role. Let's go and create a role, and I'll show you what the steps are. So if I jump into my console over here, I'm going to go and say, I want to create a role that can be assumed in this account that I'm currently using. So I'm going to go say, I want to create a role. And then what you can do is you now have to specify in the very first step who is worthy of assuming that role. In other words, who is allowed to wear the hat? And I'll just write it down over here in my little diagram and say, okay, right. So the first thing that you want to do when you create a role is you would like to say, who can wear the hat. Okay, so who can wear the hat? And this is also known as the trust policy. I'm just going to write there TP. So the trust policy for a particular role that you're creating is who's allowed to wear the hat, okay? And that is specified when you create the role in your console over here. Now, they give you all kinds of canned food that you can use here to just quickly get through the steps. But ultimately, what it's really trying to do is it's really saying you're going to try to create a role, and the role can be assumed by, and it's trying to fill out that principle over there. So if you were to go and create a role inside of your console and you say, I want to use an AWS service to assume the role, it's going to say the principal is, and it's going to say another AWS service. If you want an account to assume the role, it's going to fill out the principal entry there for the account and say another AWS account can assume the role, a web identity, right? So if a web identity can assume the role, it's going to create a web identity and say that that is the identity that can assume a role. This is the one that we'll be actually using today. It's called a SAML federation. Okay, so once again, that's just going to be the principal that can assume the role, or you can have a custom trust policy, in which case you can just fill this all out manually. Now, if you're ever curious about what exactly this principle is in an AWS policy, if you jump into your console, like just into a browser, and you type something like AWS principle, just to give you an idea of all the principles that you can get in AWS, if you go to the very first hit that's not an ad, it's going to say AWS policy elements principle, and then what you can do is you can scroll down over here, and it's going to give you a complete list of anything in AWS that can be a principle. Okay, so another account can be a principle, a role can be a principle, a role can assume a role, believe it or not. A user can, another AWS service, and so on. So there's a complete list of it. And if you want to know what the syntax is for filling out any of these things, everything is available on this page. Okay, the whole story. It's all here in one place. So that is it. That's going to be the trust policy, right? So the demo I'm going to do for you initially, before I do the federation demo, is I'm just going to say, what happens if I would like to say that I would like to trust an AWS account, whether it's my account or another account, to assume a role in this account. So I'm going to say I want to select an AWS account, and I'm just going to use my own account. And the reason why I'm doing this is because it is just faster to demo. But the behavior here, whether it was some, like my own account that's allowed to assume a role, or whether it's another account that's allowed to assume the role, the setup is pretty much identical. So if I wanted to say another account, I would just put the account ID over there. So I'm going to say I want to allow this account to assume a role in this account. Okay, so that's step one. And what I'm basically doing now is I'm saying the trust policy says that I would like to allow account 1, 2, 3, 4, 5, blah, 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 is going to be trusted to assume this role. So I'm going to go and say I want this account, and then I go and click next. And now what it wants to know is, okay, fine. You have now told us who is allowed to wear the hat. What we want to know next is, what can you do when wearing the hat? Okay, so you're over here on this end of it again, and now it's like, what can you do when wearing the hat? Okay, and that is called a permissions policy. I'm just going to write it in orange. So I'm going to say PP for permissions policy, right? And the permissions policy, and it doesn't have to be just a single one, you can attach multiple of them, is effectively the same as all of the policies that you are familiar with inside of identity and access management in AWS. So here's a long list of permission policies, and in order to make things simple, I'm just going to select one. So I'm going to say, for example, I would like to allow EC2 all access, and there's already a policy written for that. I'm just going to select it over here. Say Amazon EC2 full access. I would like whoever assumes this role, okay, which is this other account or my own account, whichever one you put in there, is going to be able to have full access to EC2 in my account. Now, you can put any permission policy that you want in there, Doesn't have to be EC2 full access. You can write custom policies. You can go to town and do anything you like. This is just a demo. So let's say EC2 full access. So I'm going to go next. And it's going to ask me for a role name. So I'm just going to say become a solution architect, and today's date, which is the 22nd of July, 2023. Okay. Let me just write it in lowercase. It's easier. July 23. Okay, so that's the name of the role. And you'll see that it's actually gone and just created this trust policy, right? So it says that you're allowed to assume a role, and the principal that's allowed to assume the role is this account. And it's given you that account ID there, and there's a summary of the permissions, create role, okay? So I've just created this role, become a solution architect. Okay, so that's 22nd of July 23, and you have permission to do anything on EC2. And that is basically what that looks like, right? So now what I want to do is, now that you understand what a role is looking like when you create it and when you set it up, let me just explain to you very quickly why you would want to understand this and what this has to do with federation. So that is our role over here. Now let me give you a practical problem that you typically run into in an organization. So in an organization, you are going to have a situation where you are going to have multiple AWS accounts. And remember, an AWS account is not a sacrosanct thing. Think of an account as a membrane. It's just something that separates one thing from another thing. It's not like the AWS account is so special. We actually, as best practice, recommend you use a lot of accounts. A lot of them, and then you consolidate them all with the organization service. But what you'll typically have is something like this, right? So let's say, for example, you've got something like this. You've got an AWS account, another AWS account, another account over here, and another account over here. And this account over here is for your production workload, for a particular workload. This one here is for a staging environment for the same workload. There's a development environment and a test environment. Once again, it's all the same workload. This is the one in production, staging, dev, and test. Now, those are all different AWS accounts, okay? And this is just a typical way that you could separate these workloads. So now you've got somebody working in your organization. So there's a person working for you, and let's call them Fred. So Fred is a developer, and Fred needs to have access to this account, this account, this account, and this account. But Fred needs to have different sets of permissions. When it comes to the production account, Fred is going to be very, very limited. In the staging account, they're going to have more permissions. In the development account, they can do almost anything they like. And then some things they can do in the test account too. So in order to make this work, right, what you would have to do if you were not using roles is you would have to go and create a user called Fred in the production account. In other words, what you would have to go into users, you log into your production account and you create a user called Fred, right? Then you log into your staging account, you create Fred again. Then you log into your dev, you see the picture here, you create the user over and over and over again. And that is not the most, effective way of doing it, because if you look at it from just the way of managing the, the permission policies, okay, so the Fred user in the production account is going to have this policy. The Fred user in the staging account is going to have that policy, and those policies are going to be different. So poor Fred over here now also has to manage 4 different sets of credentials for every one of these different accounts. And that, frankly, is a pain, okay? So, how do you get past this? How do you solve the problem? So there are 2 layers in which you can actually go and solve this problem. There's a small-scale solution, and then there is a production-scale solution. So at a very small scale, what you might want to do to start and solve this problem is you could say, well, okay, I'm not going to go and create user Fred in 4 different accounts. What I'm going to do is I'm going to say I would like to have yet another AWS account, and this account I'm just going to call users. And then what I'm going to do is I'm going to put all my users in this account, including Fred. And what I'm going to then do is to say, okay, right, so that mechanism that we use for one account to be able to assume a role in another account, we're going to apply it here. Now, let me just show you what that would look like, right? So what you will do is you will say, I would like to create a role over here, and there's going to be a trust policy, and there's going to be a permissions policy, I want to create a role here. It's going to have exactly the same thing, trust permission. There's a role here, trust permission. Okay, there's a role over here as well, trust policy, permissions policy. So the trust policy in every one of these accounts is going to say, well, this production account has a trust policy. It's like, who do I trust to assume this role? I trust this other AWS account called users to be able to assume this role inside the production account. And when they do, the permissions that they have is something like, anything that you define. In my demo, I just say EC2 all access. So let me just quickly show you what that would look like. If I go into my console and I say, I've just created a role and I want to assume this role, and let's assume it's another account. I'm just putting it in the same account because it's faster to demo. It could have been another account. It would look exactly the same. So you log into the user's account, and then you go up here and say, I would like to. You're going to say, I want to switch role. And it wants to know what account you want to switch this role into. So what I should have done a little bit earlier is I should have copied my account number. So that's a little bit faster. I'm just going to go and copy that, right? So I'm copying my account number. I'm just going to open it in a new tab over there. And then I'm going to say, I would like to switch role. So I'm going to say switch. And I'm typing the name of the account or the number of the account I want to go into, which is that one. And then I need to type the name of the role that I want to assume. So if I type in this, okay, I want to assume this role in that account. And it just happens to be the same account, but this could be a completely different account. The mechanism will look identical. So I'm going to say, I want to assume this role in this account. And I say switch role. And now what I've done is I've effectively jumped, you can say, from this account where I'm logged into this account, and I've just assumed that role in that account. Okay. So you can also see it at the top here. Initially, it said I'm logged in as Carl-ADM at account number. Now you see I'm logged in as, the name of the role and the account number over there. And if you were to now go into a service like identity and access management, you'll just see red ink all over the page. And the reason why it says access denied is because remember the permissions that you have on this role, is you can only do stuff in EC2. You can do anything in EC2, but that's the only thing that you can do something in. You're not, an admin that can do anything with any service. You should not be able to see anything here inside of identity and access management. If you go to another service like S3, for example, let's see what happens when I do that. And once again, it's just going to be, let me go into my buckets, for example, like this and see what happens. And it's just going to say, sorry, you have no permission to even look at the buckets. There's absolutely nothing you can do. However, if I were to go to EC2 and I just click on that like so, ping, it's going to let me do whatever I want. So I can see what instances are running. I can launch a new instance and so on and so forth. So that is basically the first step in how you would go and set the stuff up, right? So you have a separate account, and in that separate account, you have users. But there is a problem with this scenario. The problem with this scenario is, let's say you have in your organization 75,000 users, and those 75,000 users are all in an Active Directory domain. Remember, the maximum number of users that you can set up in an AWS account, if I go back over here, let me just switch back. The way you would switch back is you just say switch back like this. So now it's going to go right back, and now I'm logged in as myself again, the administrator here, right? So let me just close that. And if I now go back into identity and access management, like this, and I go to users, in my account, the number of users that I've currently got is 110. You cannot have more than 5,000 users inside of an AWS account. So if you're in the situation where you've got, 75,000 users in your domain, now, how are you going to do this? Are you going to go and create, a whole bunch of different user accounts and then manually copy 5,000 users at a time into every single one of those? So there's got to be a better way to do it. And the way that we do it is basically this, right? So instead of having another account that is just for users, we simply say, well, let's not put an account into the mix. We're just going to say, I would like to go and set up a thing called an identity provider. And this is something that you probably already have. So you can just say IDP or identity provider. And that is typically going to be something like you're going to have an Active Directory domain controller. Okay, so something like AD. And the reason I'm saying Active Directory is because this is the de facto standard for workforce identity and authentication. So that is what you're going to use instead. So what you'll have to do is you'll have to set up all the trust policies in all of these accounts to now, instead of trusting the other account to assume the role, you're going to have to go and set it up to do this. So when you go and create a role and you say, I want a new role, instead of saying I want to trust another account in AWS to assume the role, you're going to say, I would like to trust an identity provider, and that identity provider is going to use SAML 2.0. Because that is the protocol, the federation protocol that we use for this. Now, just a little bit of an explanation of what's happening here when you create a federation protocol, well, not when you create a federation protocol, but when you use it. So something that typically happens here is, and I'm just going to give you an analogy, right, is imagine that you are now setting up trust between your AWS account on the one hand. So here's my AWS account, okay? So I've got an account over here, and this could be the production account. Let's say for argument's sake, it's the one that we showed a little bit earlier, the production account. You're going to do this, for all of those accounts effectively. And then what you're going to do is you're going to say, okay, there is, let's say, for example, an Active Directory domain controller over here. And there's also, an IDP, identity provider, and that could be something like ADFS or Azure AD. Okay, so I'm just going to write there Azure AD because that's a common use case. And then what Microsoft will make it real easy for people who use Windows Active Directory and Azure AD to do is to just synchronize credentials between your on-premise Active Directory domain controller and your Azure AD Active Directory. So this is real easy to set up. If you use another protocol like ADFS, it's harder. Don't get too concerned about the technicalities of talking about identity providers and stuff like that. It's exactly what it is on what it says on the tin, identity provider. Now, to give you an analogy of what an identity provider does, imagine that you want to go and buy something on a website, and you go and find this website that sells this item that you really want, but it looks like a little bit of a dodgy website, or not a very professional website, but they're selling the thing that you want. Are you going to be comfortable giving your credit card number to whoever's running that website? And the answer is probably no. But what would happen if the person who's running the website, instead of saying, well, give me your credit card number, says, I accept PayPal? Now it's like, oh, wait a minute. Okay, so they've effectively federated out payment to a third-party, payment provider like PayPal. I trust PayPal. I've got a PayPal account. They've got my credit card number, and I am quite confident that they're not going to mess it up. So now what I can do is I can go to that website and say, I want to order this, and the payment should be taken care of by PayPal, and you don't get to see my credit card number or any of those details at all. So that's effectively what's happening in a way with federation, right? You've got an AWS account over here. And then what you want to do is you want to basically say, I'm not going to be managing the credentials that you're going to use to do stuff in this account. What I want to do instead is to say that I'm going to trust this identity provider. And the way that you trust an identity provider is very, very, very simple. What you basically do is you go and say, this identity provider here, using SAML identity protocol, is going to have a certification authority, and all of this stuff would just be set up on the identity provider side. You don't have to do that stuff. If you use something like Azure AD, if you use ADFS, it's a lot more complicated and involved, but Azure AD makes it really simple. So they will just go and generate the certification authority on this Azure AD account. And then what's going to happen is that thing is going to have what's known as a root CA certificate. So there's a root CA certificate inside of this Azure AD account. And this root CA certificate is going to have a private key associated with it, and also a public key that's embedded in the certificate itself. And then what's going to happen is somebody who's trying to use the service Okay, so let's say, for example, you've got a person over here, in this case, Fred. Fred now wants to use this AWS account. So what Fred's going to have to do is Fred is going to use their browser, and then they're going to go to a specific place in your AWS account, and I'll show you where that page is going to be. And then what's going to happen is your AWS account will now know when you hit that page that you need to be redirected to an identity provider to authenticate you. So what's going to happen is that it's going to redirect you back to, let's say in this case, Azure AD. And then Azure AD is going to say, log in to Azure AD. Type in your username, type in your password, whatever. So here's my credentials to log into Azure AD. And then what's going to happen is that once you're logged in to Azure AD, it's going to go and it's going to now give the user over here, Fred, a thing called a signed SAML claim. Okay. And that is just going to be stored in the browser as a cookie. So the identity provider is going to go and create this document that's called a SAML claim, and it's going to sign that document with the private key that is associated with the public key that is in that certificate. So now this user over here has got a signed SAML claim. And the way that if this user was now to go and go right back to this page and say, okay, fine, here is my signed SAML claim, log me in, the AWS account is going to evaluate whether that is trusted, because what you would have done when you set up this trust relationship is you go and export this certificate from your Azure AD account like that. You export the thing, and then you import it into your AWS account. And by virtue of importing that certificate into this account over here, you're basically saying this AWS account will trust anything that is signed by that, including a SAML claim like this. Okay. So what I'm going to do now is I'm going to show you what this would look like in this diagram over here. In other words, if we just go back, right, what we're going to try to do is to say, okay, this production account over here is trusting this identity provider, Azure AD, right? So it's going to allow Azure AD to assume, or a user from Azure AD to assume a role inside of this account. So there's going to be a trust policy here that says, I would like to trust, the following Azure AD account to assume a role inside of my account. Now, what you're going to do is you're going to go and set up your Azure AD environment first. So let me show you what that looks like. So I'm inside of an Azure AD account right now. And what I'm going to do is I'm going to begin by simply showing to you some of the users that I've got set up here. So if I go to Azure Active Directory, I'm going to go in there and you'll see that I've got some users in Azure Active Directory. Now, once again, if you have an Active Directory domain in your data center, setting that to synchronize with Azure AD is very easy and straightforward. That's not what I've done here. I don't have a domain, but if I did and I had these users in that domain, it would sync up to Azure AD like this. So I just created these in Azure AD for the demo. Right? So I got 1, 2, 3, 4 different users. And also what you can do, if I go back here, you can go and create groups. And what do you know? I've created a group called Power Rangers. Not very imaginative, but some of these users in my Azure AD users are in this Power Rangers group. So I got one group and I got 4 users. Right. So now what you're going to do is you're basically going to go into, let me just quickly see where I've set that up. Right. I'm going to go back into my AWS account. Right. And I'm going to go into AWS Identity Center. Yes. And this is a place where you go and set up that very, very special page that people can connect to if they want to assume a role inside of your account. Now, there are a number of different external identities that it would allow you to use. And you can also use internal. Any of those will do just fine. What I've done is I've used an external provider. And if you go and set this up, and by the way, If you're curious about the minutiae and the steps of setting it up, I will share a link. There's a YouTube video that actually shows you exactly how to do all of these steps. I'm not going to show you all the steps to set it up. I'm just going to show you what it looks like when it has been set up and what it, the overall architecture looks like. So if I go into Identity Center, I'm just going to go and say I want to create a new, a new landing zone or whatever it's called for this particular region in this particular account. And once you've gone and done it, it basically looks like this. So I'll just show you what some of the settings look like. If I go down here and I go into Actions and I say, I would like to manage authentication. Okay, what it's going to do is it's going to have some information about my identity provider, and it's going to have some information about my AWS account, which is known as the service provider, right? So these things will be provided by AWS, and this stuff will be provided by the Azure account. And then you're going to import the certificate from your Azure AD account over here. Now, if I were to go back in here and I just say settings, and I say actions, and I say I would like to change the identity source, you can see that I'm currently using this. Now, just to give you some more context, the identity source for the identity center does not necessarily have to be this. You can also say, I just want to create a little directory inside of Identity Center. Or you can say, I just want to use Active Directory directly running in the data center using, Amazon Active Directory connector to be able to talk to that, or Active Directory running inside of my AWS account. But for this demo specifically, I wanted to show you how federation works. So I'm going to say I want to use an external identity provider, and that then is Azure AD. So where you set up all of this stuff is if I just jump back into Azure AD, I've shown you the users that I've created, and I've shown you the groups that I've created. If I now go back to just the main page in Azure, you're going to go and set up in your Azure account an enterprise app, and you can go and say a new application, and you can search for it. And there's an application called AWS Single Sign-On with Azure AD. And if I click on that, what you'll see, okay, is that there is under, let me just see, where is it? Single sign-on. Some basic configuration, some attributes and claims, some SAML certificates, and you'll see what happens is, and this is stuff that happens during the setup process when you go and create this, when we create this little account inside of Azure AD. The bits that I'm not showing you in this demo, but it's in the video, the YouTube video I'll show you later. So what you're going to do is you're going to go and get for yourself these little URLs over here. These are automatically generated by Azure AD, okay? So you're going to copy and paste those one by one. And then what you're going to do is you're going to go to your AWS account. And when you set up your identity center over there, and I'll just show you where those went, and say actions, manage authentication. Okay. You see there the identity provider metadata, those links over there. Okay. Those are just things that I've copied from over here. Right. And the other thing that's very important is up here, you'll see there is a SAML certificate that's going to sign all those SAML claims. And I can just download the certificate over here. In other words, what I'm really doing is, if I just drag this to the right to show you what the step is that's happening over here, right, is that certificate over there, I can simply export. And then if I go into my AWS account again, you see that the certificate here can be imported quite simple. Just say import certificate, select the thing, and there it goes. And then what you've effectively done is you've gone and set up the trust relationship between your Azure AD account and your AWS account. Right. So one more thing that is now going to be necessary is that the place that this character Fred over here needs to go to when they're trying to do something in this AWS account. And that is also provided here. If I just go to the dashboard in my Identity Center, it will say the AWS Access Portal URL is going to be this. And this is something that you give to your end users. So that is where they need to go if they want to log in with this federated identity system into your Identity Center. So instead of just saying, I want to log into my AWS account, and you go to the login page, you don't go there, you go to this page specifically. So this is what you give your end users, and that's how they're going to log in. And if they were now, after you've configured all of this stuff, if you've now gone and said, okay, I want to log in with that, once again, the procedure basically just looks like this. So you've got a character over here, Fred. You're going to go to that URL on the AWS account and say, click, bam, and it's going to load. And as soon as this is loaded, immediately it will see that the identity source for this is Azure AD. So it's going to redirect you to Azure AD's login page. And then user over here is going to log in to Azure AD with their username and password for Azure AD. Nothing to do with AWS. And once they've logged in, then what's going to happen is Azure AD is going to issue to them a SAML claim, and it's going to sign that SAML claim with the private key that's associated with the certificate that is already imported into that account. So the private key is going to sign it. They're going to issue this SAML claim to Fred, and this is going to be stored in the browser as a cookie. And then Fred's going to go right back to this AWS account page and say, okay, log me in. And he's going to say, okay, I accept that SAML claim. Thank you very much. And you're now going to be able to log into this. So that is basically how that works. Now, one more little piece of the puzzle that we need to talk about is to say, okay, how exactly do you now go and map permissions that you have in your AWS account with the permissions that you have for that particular group in Azure AD, right? So that's the last little piece of the puzzle that you need to map. And for that, I've actually got a slide here that I'm just going to show you. So the first step is you go and set up your users in Azure AD. And then what you're going to do is you're going to set up, there's a protocol, and I'm not going to talk about it here, that will make it real easy to do. It's called SCIM. And the SCIM protocol is, if you set that up between Azure AD and your AWS account, is it's going to automatically push all of those users and groups from Azure AD into your AWS account. Once again, the YouTube video will have more information on how to set that up. But it's a protocol called SCIM. And if I go into my AWS account over here, and I go to users in AWS Identity Center, you'll see that those users have now been pushed into my AWS Identity Center. And I can also see the groups. So there's the Power Ranger group, and all of that stuff just happens. If I make a change to the group membership or the user membership of groups and settings, all of that stuff will then be pushed into my AWS account, into the Identity Center over here. So that can then be represented graphically like this, okay? So that just gets pushed in there automatically. And then the other thing that you're going to do is you're going to go and say, I would like to create what's known as a permission set in AWS. And this permission set is the thing that's effectively mapping. And what the mapping is that it creates is basically this. So let me just draw that on the screen for you. So in Azure AD, okay, so this pen isn't always working very well. Sometimes it's a little bit finicky. So in Azure AD, okay, you've got users and groups, and then the Azure AD is going to map. So this is going to have groups. I was going to say groups over there. And these groups in Azure AD, you want to map to roles in your AWS account, right? So there's going to be a mapping. The groups in Azure AD, so you've got people in a particular group, Power Rangers, you want that to now map to a particular role that you've created in AWS. So the place where you go and do all of that stuff in Identity Center, just get rid of this. Okay, because I'm going to go in there like that, and I'm going to go to permission sets right here in Identity Center. Okay, so I'm in permission sets over here, and I'm going to say I want to create a new permission set, custom or predefined, doesn't matter. Go next. And I can select the policies that I want to apply to it. So I can say, for example, I would like to allow, let's say, for example, S3, allow all access. So if I'm going to say Amazon S3 full access, I want to allow that as a permissions policy when this role is assumed. And then I go down and say next. And I'm just going to give this permission set a name. So I'm going to say PISA demo S3. Should actually not have a dash there. Okay. And the duration that the session is valid. So how long can this role be assumed for? Anything from 1 to 12 hours. I'm just going to go next. Okay. And then I'm going to say create. So it's now going to go and create a permission set for that. So there it is, Bisa demo 3. And one other thing that I still need to do now that I've created this permission set, and this is quite powerful, is I can now say, okay, in my organization, I might have more than one AWS account. I can have 10 or 100 or 200 accounts. In which one of those accounts would you like this role to be assumable? In other words, if I now go back to this step over here, okay, so let's say I've got 1, 2, 3, 4 AWS accounts. What I've done is I've just gone and created a permission set with a role that says, okay, you're allowed to do anything in S3. Now, what accounts do you want that to apply to in your organization? And now you can just go and define exactly which ones of those you want to define or you want it to apply to. So you can go into your AWS accounts over here, and it will show you your organization root structure. So I can just go in there and select, I've got that account, and I've got another account here called that. And then finally, I've got that account. So 3 accounts in my organization. And I'm just going to say I want to assign users or groups. I'm going to say I want to assign power ranges. Next. And the permission set I want to map that to is going to be Bisa demo S3. Okay, so those are the permissions and those are the accounts. I'm going to say submit. Right. So now it's just going to quickly configure it. And now once this is done, everything is pretty much set up. So what we can now do is we can now go through this procedure as an end user, and I'll just show you what the flow looks like. Okay. So what I'm going to do is, let me just quickly, I've got a copy here of my password that I just need to log in. So what I'm going to do is I'm going to go into this page over here, like that, and I'm going to copy this login. So I'm going to go to the dashboard and say, I would like to go to this portal. So I'm going to copy that. And I'm going to paste it in here like this, right? So this is my AWS landing page, effectively. So I'm clicking on that. And as soon as I do that, you'll see that it's redirecting me to my identity provider. So I've hit the AWS page, and now I'm back at the IDP, and now it wants to sign me into Azure. So I'm going to sign into Azure as this Yoda user. So let me just copy that. So this is the name of my Azure user that I want to use to sign in, is that one. I'm going to go next. It wants my password, so I'm going to type that. Okay, next. Sure, I want to stay signed in, no worries. And now it's directing me right back to AWS. And now what you can see over here is my entire organization and 3 different accounts that I've just assigned. And I can say, I can now go and assume, and I've set up a few other things before this, but I can now go and assume this role in this account. I can assume this role in this account, and I can assume this role in this account. So let's say, for example, I want to just go and assume this role in the account. What I'll do is I'll say, let me go and assume it. So what we're basically doing is this, right? So this whole process is now being completed. What we're doing next is this. So I'm going to say, okay, I would now like to go and assume a specific role in the production account. But you can see all of those accounts are listed over here for you, right? Sorry if I just go back here. So there is 1 account, 2 accounts. That could be production, staging, test, development, whatever. And then all the roles that are available to you to assume would be here. So I'm going to say I want to assume that one. So that's effectively doing something like this. Let's just say I'm assuming this role. Okay, that's the one that gives me access to S3 for everything. Permission policy says S3 and all access. Trust policy says, I trust this identity to assume the role. So I'm going to do that. And all you have to do as an end user is to say, I want to click into the management console. So click. And now it's just going to sign me into that account. And the mechanism here, that I'm using for this is the same mechanism that you've seen earlier when I said, I would like to assume a role in another account. Okay. But in this case, instead of trusting the other user account in AWS, it's trusting the identity provider. And you'll see up here now, if I just go next, just get rid of all of this stuff over here. Next, done. Okay. That I am now logged into this account here as Bisa demo 3. Okay. So that is the role basically. And then / and there's my federated identity. So Yoda at, whatever.onmicrosoft.com. And I've got permission to do anything I want to in S3. So once again, if I go to identity and access management, the permission policy that applies will not allow me to see anything here. It'll just be red ink, which is absolutely expected. But if I were now to go to something like S3, suddenly I'll be able to do anything I want. And there's all my S3 buckets, and I can do whatever I want in S3. So that is basically the idea. I think I've talked for 46 minutes, and I will just stop it here. I don't know if we probably don't have time for questions. So my apologies for that. I just wanted to give you a demo and just give you an overview of how this works. It's a little bit of a tight order to squeeze it into 45 minutes, but I think I've hopefully achieved that. I don't want to take up any more time, but that is how you do that. What I'm going to do now is I'm just going to give the link to the YouTube videos as a final thing. Let me just go in there. I think it's over here, right? So there are 2 YouTube videos. One is if you want to set it all up for AWS, single sign-on with Azure AD. And I can't put anything in the chat directly, so I'm going to put it in the private chat. So I think maybe Parna will be able to put that into the group chat. And then if you want to do single sign-on with something else like Okta instead of Azure AD, you can use this. So I'm just putting that in there like so. Okay. So that is it from me, folks. Back over to you, Asish.
Thank you, Carol. It was interesting, and somehow my camera is behaving weirdly, so I am still in front of camera, but what you see is invisible. So yeah, I've become like an invisible man. This is what is happening right now, but that was interesting, and thank you so much for showing that up. I'm sure that this was a very enterprise ready use case, and people would have understood that how all these concepts actually apply and what it takes to have those certificate exported and included. So thanks for that. And the link you shared, and obviously they are going to be useful. So we would be putting that in our resources space. So anyone who is trying to look at the session on a YouTube recording, maybe you can't access the live chat, but you should be able to access the link which is there. Matthew, I like your comment. Ashish is now assuming role of a hollow man. Yeah, means my camera is weirdly behaving, so it is not showing me at all. It has just captured a frame and then it is showing up. But thank you so much, and we hope to see you in some other sessions, Carl, also. And thanks for if there are any questions which we were able to capture, I'll probably will be sending it to you, and then offline we could get answer and reply back to people.
Absolutely.
Thank you so much.
You're
Now I'm
most
going
welcome.
to add Eric to the call. Thanks, Eric, and sorry for keeping you wait. I'm
Oh, you're
adding
fine.
Eric.
That was great stuff, Carol. That was very interesting.
Thanks, Eric.
I have wrestled with that before in my life, so it was really good to see an expert do it and not not myself.
Well, I
So
couldn't
that
call
was
myself
very
an
good.
expert. I just know how to follow instructions.
Well, that is an expert in today's world sometimes. So well done.
True.
Thank you.
Yeah.
And interesting thing is like there are lots and lots of use cases for this scenario. We just talked about Azure ID, but it could be anything. It could be any identity provider you created or you wanted to create or whatever. Now I'm back. So yeah, role assumption token is
Welcome.
lost. So I'm here now. But yeah, that was interesting. So thanks, Carl, and hope to see you in another session. Over to you, Eric,
Absolutely.
and we will talk about the day in the life of Eric Johnson, a principal developer advocate into AWS. And I will add Prasad also. Prasad may be also interested to ask some question. So I hope this thing is visible.
Let me reframe it.
Yeah,
Yeah,
that is
now
better.
Eric has the spotlight.
Hey, Prasad.
Hey, Eric, how are you doing?
Good to see you. Yeah,
Good to
I'm
see you,
good.
man.
Good, thank you. It's quite early here in Colorado.
I
I'm coming from
know.
Colorado. No, that's
And
not a complaint. You'll hear the complaints offline. No, it's great. My wife was like, "You're gonna what? Well, don't be loud." Which is, I am gonna be loud because I'm Eric Johnson. So I'm sure she's right now going, "Oh my gosh." So, but good to be here.
Thank you so much.
Thank you so
So
much.
Eric, let's jump into question here, and we want to understand what is a developer advocate first of all. Means it looks like a very fancy word to me. That are you a legal person or are you a developer? Who are you?
Yeah, it's funny that there's developer in my role. If you go to some of my past employers, they would, is he really a developer? I don't know. I'm more of an architect, but I can't. That's a joke. I can develop, and I'm probably not going to be in the best of the room. But the principal idea of a developer is twofold, and it looks different from person to person because we all have our own skill sets, right? But if you kind of take it and just look at it a generic way, a developer advocate's job is to, one, advocate for the developer, right, to the company, right? So as developers give us feedback, look, Eric, this product is or isn't working, or this feature is great for us, we love it, or I wish we could shave off these. I'm sorry, goodness. Y'all hear me okay, right?
Yeah.
Okay, good. I wish we could shave off these sharp edges or whatever feedback they may have. We bring that back to the company. And what's interesting is it's not just, I have this feedback and I write a doc or something like that. We actually sit with the product managers. I sit with the guys and girls who are creating, AWS SAM or API Gateway or AWS Lambda or whatever. In fact, I remember when I first started here, I was such a, before I came to AWS, I was such a huge fan of serverless. I mean, I'm an absolute fanboy. And I met one of the SDEs who was building Lambda. And I was like, oh my gosh! I mean, it was like I was meeting a superstar or a basketball player. I was so excited. But we sit with them and we give them feedback, and they actually will come to us as well. It's like, look, we're getting ready to try this new thing, or what do developers think about, whatever. And so we do that. The second thing we do, obviously, if you watch Twitter at all, is we advocate for the companies, the customer, right? So we tell customers about, hey, or develop. I'm going to say developers because that's really more my, I don't talk to companies or as a sales things or anything like that. I'm more of we are one to many for developers, right? That's who we talk to, and so we'll spend a lot of time telling them. We teach. So if you were to break down my life and say, Eric, what are the two things you do? It's like I develop and I tell others about it. You know what I mean? So we do a lot of playing around and proof of concepts and edge cases and best practices, and then we go out and we teach that to the customers. Whew, that was a mouthful. Hopefully that helps. That doesn't fit on a business card.
Yeah.
That's great. One question before we move further, and we forgot, was because we have heard so many talks about you that we know everything about you, but a lot of our audience might not be knowing about you as a person. So would you like to introduce yourself first?
Yeah. So again, my name is Eric Johnson. You see there, that's my Twitter handle there. I am a principal developer advocate for AWS. My primary area of focus is serverless and event-driven architecture. Although I mean, we definitely, we've been working with AI, but who isn't working with AI right now, right? And so we work with database, we work with a lot of different things because serverless just kind of makes sense for a lot of those. I am based out of Colorado. A little personal information. I'm based out of Colorado. I have 5 kids, which is, and that is a 5. If you're watching, go, that's not a 5. That's any number I want it to be. Those are the rules when I talk. So I'll hold that up and say all kinds of things. But I have 5 kids, 3 boys, 2 girls. I'm a drummer. And probably a lot of people are like, really? Yeah, I went to, here's the truth about that. I went to school for music, right? I was going to be a drummer. That was going to be my living. But here's what I learned. It turns out I'm a really good drummer for one finger. But once you get past that, I'm pretty average and nobody's going to pay me to do it professionally. So here I am, and so, yeah. And I my favorite part of the job, I love speaking. I love teaching. I love students. So hopefully that tells a little bit about who I am, and I'll answer any question on that as well.
Thanks for asking that question and thanks for answering that, Eric. for me, like we know Eric so much, like I never felt that I had to get him introduced. But yeah, thanks for that, Prasad. And
Yeah, you
yeah,
bet.
so Eric, like tell us like on what you do on a day-to-day basis. Like you explain a little bit on that, but if we let's say we break it down into like smaller chunks of time, what is your day-to-day activities?
Yeah. So that's a tough one. Not because I don't do anything. I mean, that I do, but I mean, it changes from day to day. I kind of gave you the guidelines of what we do. Um, but how we approach it, a lot of people see, I talk to a lot of people. A lot of people would love to be a DA. I would love to be a DA. It'd be fun. What they see is the very, and I know this is an analogy we use all the time, but it's true. They see the very tip of the iceberg. The speaking. I want to be on stage and I want to speak, and I do too. That's my favorite part of the job. But during the day, we spend a lot of time. One of the things we do a lot of is just research and proof of concept. Does this work? How does this work? We spend a lot of time. I mean, I know the console pretty well. I spend a lot of time in the AWS console. I spend even more time in the CLI, the AWS SAM CLI or building things out. So we spend a lot of time building things. When I go out and speak at a conference, anything I speak about, I will have built multiple times. I will literally sit and think, okay, if I'm building this, if I were a developer coming from this angle, what questions would I ask? And then I'll build to that, does this work? Does that work? How do I use SAML? And what if I wanted to use Okta instead of, whatever? And so we try to look at that and then we build them. So that's one of the things that happens during the day. I work for AWS. We do a lot of writing. If you know anything about AWS, we write. If you know anything about Eric Johnson, he's not a great writer. So that's always an agonizing process for me. It's like, oh, I love it, and it's a good challenge. It's a muscle that I don't get to work as much, but that's another thing that we'll do in the day. And what are we writing? A lot of what we are is we write. I mean, we write documents on. For example, I'm a better storyteller than I am just listing things off. Last year, one of the things that I was really interested in, I love students. I have just a passion for students. I really was seeing as I was talking, I had this chance to talk to a series of students from all across the United States and Canada. They were like, 80, 90 students in the room. And it was an open forum. They got to ask me questions. And when I started asking them, I was really surprised that about what they were learning in university, or more to the point, what they weren't learning in university. And so I really had a passion for, look, I think we need to be teaching serverless. I think we need to be teaching event-driven architecture. I think we need to be teaching, what I was hearing, what language are you learning? These are, CS students, computer science students. Well, we're learning C++, which is great. C++ is a great language. But it's like, well, okay, but where's your Python? Where's your Java? Where's your, these are the things that are very common in the modern world, And so I wrote a doc on taking serverless into the education world and spending time with it. And so that was a long, arduous process and when you write here, it gets judged. Not judged is the right word, evaluated. You both know. And so when you write, it's like, and many times I've gotten a doc back. This is, you need to rewrite this. And so that's another part of the day. Part of the day is doing this. And usually it's not this early for those, like I said, for those of you who are just joining or whatever, it's like 3:00 in the morning where I'm at. No, it's coming up on 4 now. And but I love this, and so I don't mind getting up and doing this, and I'll just go right back to bed in a little bit. But you do this kind of stuff, and then we travel. We get on planes. We go last year because of, if you've never heard of it, Serverless Espresso is something that our team built, and it's a demonstration of serverless that we showed all over the world. And I was on every continent on the planet except for Antarctica last year. And so we travel. So that, and I'm sure there's more that I'm missing, but I'll kind of pause there. That kind of gives you an idea of a lot of what we do.
That makes
That
sense.
sounds really interesting. Also, like as a role, it's quite exciting, and it has too many facets. So if someone wants to become a developer advocate, what steps they should be taking to reach there?
So the things I would work on, first of all, let me address what you just said. It is exciting. I mean, I'm not gonna lie. I love my job. Now, when you ask my kids what I do, they're like, I don't know. It seems like he's yelling in the office a lot and laughing, and then he travels. So that's what they think I do, or they work for Amazon, and people go, "Oh, your dad works for Amazon? Does he deliver?" Yeah, he delivers. It's just easier for them to say that. But yes, I love my job. I love what I do. The road to a developer advocate has many different paths, but I think the thing you start with is teaching others. So you wrap that. That's kind of your central thing. I want to teach others. Do I do that through stage? That's each of our team have different gifts. Mine is really that's I like to be on stage. I like to teach from stage. I like that person to person. And all of our team is good at that. I'm not saying I'm better or worse. That's just my passion. But you take someone like Marcia. She is an amazing video and blog writer. James writes a novel every day. I mean, he's such a prolific writer. And so we all have our different gifts. But it all comes back to the core of teaching. And so if I were to tell someone how to kind of move to this role, I would say start teaching. Learn, and then whatever you learn, teach, right? A lot of times we learn something and just stays here, but whatever you learn, it's kind of like what y'all are doing, and I told you offline, so I'll say it online as well. This is a fabulous program. You're taking the time, you have a passion to engage and enable others to keep moving. And that's kind of the mindset. And so let's put that into practical, that's great, Eric, but let's get practical for a minute. Write blogs, do video streams, have code examples, just create a library of example of teaching, right? And so that's what we would look for. If I'm looking for someone let's say we're going to add another DA to our team, we're going to start really searching who's impacting others by teaching. And there are people that just have this natural gift for it, right? And there's so again, that was practical things of have a library. Don't just learn something and keep it hidden. Have a Git repo going that people can look at. Get a blog up and running that people can read. Start a YouTube channel, and it doesn't have to be perfect. It doesn't have to be. It's more about the content than the framing and the fanciness. So that's where I would start.
Cool.
Amazing.
Thanks.
Yeah, you bet.
When we are talking about your communication with developers, so is it about collecting feedback or making them aware more about what is available, or is it both ways?
It's definitely both. Yeah. So we call it outbound, inbound, right? And one of the things we talk about is our team is what's called a one-to-many. We rarely will our team be the one that goes and sits with a company. We are more of the conference and those kinds of things. Sometimes we do, and some of the bigger companies, they'll bring us in and say, hey, we want you to present at this company, and that's great. But it's very much about bringing the information. One of the battles any product has, even at AWS, is awareness. Here's a great example. Last night or yesterday, I was helping someone actually on Stack Overflow, and the question was API gateway and how do you manage multiple versions of an API. And we have stages in API gateway, and it's a viable way of doing it, but it's not the easiest way to do it, to be honest. A better way or best practice for that is to do it in custom domains with base path mapping. And this isn't a tech, so I won't go into all that. But I didn't. So I helped him, and then I'll often, and again, this is back to that teaching rather than just holding that information. Whenever I have something I think someone struggled with, I'll do what I call a pro tip on Twitter, and I'll say, API gateway pro tip when using base path, or if you're looking to support multiple stages or multiple versions of an API and you're using stages, stop. A better way to do that is in the whole thing. And that tweet kind of blew up on me. It was in a good way, but as people go, I didn't know that. Oh my gosh, I'd never heard of this. And we sit back in kind of in our, well, we're AWS, so we've got these products about. I'm sure you've heard about it, but they haven't. And so awareness is always a battle, even in big companies like AWS. Did you know? We spent a lot of time going, what did you know? I never knew that, and so that's a lot of what we're doing. But then the other side of it is, it's almost a 50-50 where we're bringing back, we do, the hallway track, as you know, is so critical. Reinvent, or even small ones. We sit with customers and we'll build something and go, that's great. And then we get it out there and customers are going, or developers are going, I would never use this, or I would never, or this doesn't work the way I expected. And so we go, oh, okay. So let me go back to developer. And one of the cool things about AWS, about the teams I work with, is they're very open to going, oh, okay, we didn't realize that. Or, they do a lot of study beforehand, but sometimes you just, sometimes you got to steer it a little bit. And so they react. The quote that 95% of everything we build at AWS is customer driven. That's very true. It's absolutely true. And so that two-way, I took this into, I didn't mean to take it to like a commercial here, but that two-way communication is critical. So yeah, to answer your question in shorthand is yes. Ashish, you're right, both.
No, and a great tip that you gave is that, it's not only about, solving one developer a problem, it's about scaling it so that it reaches the maximum people. That's where the whole, advocacy probably comes into picture. But how often do you work with customers directly? There is one question that I'm going to pop in here. But how do you go about convincing customers about new features? Like one way is obviously you do it through evangelizing on like reInvent and like other public forums. But is there do you have one-to-one customer meetings, or is it more solutions architect?
Mostly solutions architects will do the one-to-one. Like I said, we'll come in on some of the bigger customers, or if we've had like things we've produced where that we'll have I have this does tie in. I have a series that I did when I first started. It was quite a few years ago, about 3 years ago, called Happy Little APIs. And Happy Little APIs goes through all the features and stuff of API Gateway, but it's done kind of if you're familiar with the Bob Ross, Happy Little painting and stuff. But it's just, we have fun, And I think it was, I don't think I should say customers, but a very, very large customer found that and made that required viewing for any of their new people. And they ended up having me come in and say, would you kind of present stuff like that? So that's when we'll go into big ones. But to kind of answer your question, with serverless, I don't know if I've always had to convince. It's more just about teaching. A lot of... In the world of computers in general, how many times does the answer to a technical question start with, it depends? We say that all the time. Well, it depends. There are 101 ways to do that. Which is easiest for you? And so a lot of what it is, it's not so much convincing, but it is about awareness. Did you know? This is how we would do that. This is how we would do that. Now, there might be some convincing when we say, this technology versus this technology when it comes down to comparison between two. And then we'll talk about the benefits and things like that. But mainly my job is to educate about the existence of and not convince you to use. I'm not really part of the marketing group per se. So I don't know if that answered your question, Chandrasekhar. Did I get that right? I'm working on it.
Yeah.
But hopefully do a follow-up if it didn't, and I'm glad to answer another one. So
that gives an idea exactly. Now I'm talking more on the structural part of being a developer advocate. So like you take care of serverless. So are there any different stream within a developer advocate pillar, like maybe for serverless, maybe for traditional EC2s kind of stuff?
Yeah. So at AWS, and that's a great question because you'll see there's 1,000,000,001 developer advocates. I'm a developer advocate for AWS. Oh my gosh, another one. There are a lot of us, but we do have different areas. So first of all, it starts out there's two types of developer advocates at AWS. there's a marketing developer advocate, and they're
Okay.
probably, and I don't want to say this is, I mean, I'm not going to put a box on them, put some guidelines, but they're very fuzzy, right? But the marketing developer advocate team, they're amazing. You see them all over. They're doing some crazy things. They're probably a little more outbound than we are, although they do inbound, but they're probably more focused on outbound. And that's a whole group, and they're an incredibly technical team. So what I'm going to say is not despairing at all. They're more mile wide, inch deep, although they're mile wide and mile deep on a lot of stuff too. They're an incredibly technical team. I mean, I can name, I mass respect. We are very narrow, very deep. We are what are called a product aligned team. So all I do is eat and breathe and dream serverless. If you ask me to describe a network with CIDR ranges, things like that, I'm not even sure I could do a VPC anymore. You know, it's been so long since I've done. That's not true. I mean, obviously we deal with that, but we deal with serverless more than anything. So, and there are some for containers. We have some for, with DynamoDB. There's some for Amplify. So not every product has their own DA, but many do. But then when those who don't, that marketing DA team steps in a lot and helps out, and they really kind of cover the gamut. So between those two teams, you get a lot of different folks, and it's a great coverage.
Great. Makes sense. And yeah, that answers the question. Now, on the similar career track, I have another question. Like, if somebody is starting new, so there would be hopefully a associate level, and then a developer advocate, and then senior, and then principal. So how these responsibility may differ for a associate level or a senior level or a principal level like you?
How do you divide between them?
Yeah, means as a junior, I would do more X. As a principal, I would do more Y.
Yeah, I tell you, I'm a principal developer advocate, but I have no idea how I got here. So
Okay.
I think I pulled the smoke over someone's eyes. No, I'm just kidding.
That was actually my. How did you become one? You know, like, but yeah. Let's first get into this, and then we'll
I remember when they
that.
called me. I remember when Chris called me and said, "You are now a principal." I'm like, I am. I'm just kidding. There's a lot of work to it, but so we obviously inside AWS, inside this role, like any other at AWS, there's very specific guidelines, right? There's things you check. For us, I'll start with the principal, kind of work down. And won't be hard for everything or hard line for everything, but for me, for the principal, one of the things that we say is at that L7 internally, that's what we call that. You have a lot of influence outside your role. You are working cross organization. You are influencing in a lot of areas. So that's kind of one of the things that kind of says, okay, that's an L7. And so I work with teams across serverless, but I work with teams outside of serverless. I work with teams, DynamoDB, which is serverless, but it's not really in our purview, or AI ML, working with that team, things like SageMaker, and so that's one of the areas that would be that. As a senior, so step down, or as a senior, that's more independent, you're kind of in your lane, a little more concrete job description, and probably more just working within in your area in the serverless, and that's where a lot of us started. In fact, everybody on our team came in as seniors, and so we had already had an established kind of following outside AWS. Although I'll be honest, and here's the truth: when I came to AWS, I had about, and it's not about followers on Twitter, but this is the number I'll use for a moment. I only had maybe like 400 followers on Twitter. Right, I wasn't terribly well known. What I was doing, I'm a speaker, and that's where that kind of lined up for me. So when I came in, for me to go from senior to principal, I really had to lock down this, more than just speaking. One, I had to lock down my writing. We talked about that earlier. I write like I speak, which works on the stage, does not work in an AWS technical document, right? It's like, hey, dude, let me tell you about something. It's like, no, Eric, that's not how we write here. I was like, oh, okay. So I had to really up my game on that. That kind of helped. as far as there are not, we really don't bring anything lower in our team at this moment, so I don't have guidance for an associate or just a regular level. But like anywhere in AWS, it's a starting point. If you're coming in as an intern, I have a very good friend. I'll talk about the essays from. I have a very good friend in Bahrain. I've learned to say that correctly. And she came in front. She came into the AWS intern. It's fantastic. She's just incredible, very technical. Zainab, if you're watching, I'm talking about you. And she going through that, and then she'll go through the leveling up. She came in. After the internship, she came in as an L5, and that's what makes sense, right? So that's that associate level. I'm sorry, that's that SA level. It's not associate. It's the SA level, and so. I don't know. I don't know if that was helpful. I think I properly ran around that question, but let's see if that helps.
No, I mean, that
I may get a
completely
call from James later. You can't say that.
we would remove it from recording.
No. It'll be all
No, but
right.
that's interesting. Yeah, that's a good to have that. And yeah, means that is so many things because just the title doesn't tell all the story, and that's why we wanted to hear from all of you, like a day in the life of a person in AWS. So that is good.
Yeah.
Now,
Yeah.
what are some of the challenges and what are some of the perks being a developer advocate?
Some of the challenges and the perks.
Yeah,
I'd say the rest of the team, they would say the challenge is me. And for me, the perk is the
yeah,
teams.
I agree.
What do you mean you agree? Just kidding. The challenge, I think the challenge is there are a lot. I mean, earlier I said I love my job. This is one of those jobs I would do for free if my wife would let me, right? I mean, it's like, no, you need to get paid. But this is a fun job. I think the challenge is all the work that goes on behind the scenes. It's a busy job. It's a lot of work. It is not a 8 to 5, 40-hour. I think some of the challenges are the time spent on the road. We don't do a ton. We're set at about 25%, and that's a good mix. But last year, post pandemic, we kind of came back with a vengeance, right? It's like, go everywhere, And so that was a little bit of a challenge on one part, but fun on the other. The other challenges are, just some of the things we do. A lot of the things we do at AWS, we're solving very hard problems. Yeah. Distributed applications are very hard, right? Item potency, syncing, quorum, all the things that I'm just saying words. I don't know what they mean now, but things that people struggle with, we're solving those. And our job is to kind of take this very complex idea and break it down to consumable parts. Yeah. So an interesting thing about that is I see that as a challenge and a perk, because the challenge is, I mean, sometimes we look at something and go, oh my God, I'm not even sure I understand it. Okay, let's work through this. But then when you've got it, it's like, all right, that's that, because there's nothing cooler. My boss would tell you, James Bezick is my boss, who I love dearly, but I would deny saying that because, we got to keep him on his toes. But he would tell you, I just love the travel. And I do. I love the travel. But my favorite thing about the job is to see the light go on in a developer's eyes. I get that. I can use that, and I'm ready. But that's I appreciate that. But that's the perk followed by the challenge. So that's kind of the linear movement of those two. Other challenges, I guess, trying to explain my job again. My mom couldn't tell you what I do. My kids, they're hysterical trying to explain to people what I do. And so, I mean, hopefully that helps. I don't know if I'm sure there's more, but and glad to answer questions on some of those, but those are the things that come to mind.
It does.
One thing
and the writing. The writing's a challenge for me.
Oh, okay.
Yeah.
No, one thing I'll encourage everyone is that, like just go to YouTube and search for Eric's, like videos. If you love this video, listen his full videos. You'll absolutely love them.
Exactly.
And he travels a lot, so he would be in your city in one form or the other. Like whether it is go to
Probably so.
events or AWS summits or reInvent, and most of them are like mostly free. AWS summits are free. And if you're in a AWS Summit, search if Eric's session is there and go for it. It might be difficult
Thank you.
for you to get us, like a seat.
Yeah,
You need to line up a bit, but yes.
Thank you very much. I appreciate that. I like to talk. You get me going and I enjoy it. This is the perk.
And we love to hear, like when you are speaking, we get engrossed. So yeah, that's great.
Thank you. Thank you.
Now, I would like to take one question from audience Pawan, and he is talking about there's a good and bad about like what are the pros and cons of serverless architecture. If let's say it's like a diplomatic question or obviously kind of an interview question, I would say it's common to have. So yeah, what do you think is how you would define pros and cons of serverless architecture?
The pros is it's the best technology on the planet. The cons are it's hard to spell. There you go. No, let me give you a real answer. So, like any technology, and again, back to this, it depends. There's a million ways to do things like that. I think the pros of serverless are out of the box with serverless, you get event-driven architecture. And so I'm going to move to EDA instead of serverless for the moment, and I'll come back to serverless. But event-driven architecture solves a lot of problems. It solves the problems of scalability. It solves the problems of coupling. Let's put the caveats, right? Oh, by the way, another rule when I'm talking, these are quotes, not apostrophes, and I know that, so it's better than this, right? But let's put some guidelines around what I'm going to say here. If done right, and you say that about any technology, if done right, EDA or event-driven architecture gives you a lot of right out of the box, scaling, decoupled architecture, a lot of resiliency, a lot of durability. There's a lot of things that sometimes we have to manage when we're auto scaling systems, when we're taping memory and storage to the side of our boxes, trying to get them to go faster and better. So a lot of that's handled, and so serverless gives that to you right out of the box, and then you get into the serverless part of that and say, look, scaling, a Lambda function scales automatically. You aren't managing that. The step functions allows you to orchestrate without writing code. You aren't having to write the code and manage that. And so I could go on and on and on and on the benefits and stuff. The challenge, I think, of serverless is it's not just a new syntax. A lot of times when we go from one language to another, it's I understand it. I just have to learn the syntax. So I'm going from Python to JavaScript. I just say, what if I were going to do a loop in Python, what does that look in JavaScript? We get the syntax, we move on, right? It's the same conceptual idea. With serverless, you're changing your mindset. You're changing this idea of functional programming, linear programming, APIs constantly, to the idea of events. You're really getting rolled into this event-driven architecture, which, while is a challenge, is a good thing. Now, we didn't invent EDA. EDA has been around for a long time, but I think we made it a lot easier for folks. Again, we're taking very hard problems and making it easier. But it is, when I sit and explain, the idea of event-driven Lambda function or direct integration from API gateway to DynamoDB with VTL, which what that's gonna and so those kinds of things, and you see people just kind of go, oh my gosh, this is hard, and there is some things that are hard there, but we're constantly working to make it easier. But that's the challenge, is changing your mindset. But again, when you're in the room and the student goes, and the student doesn't have to be in a school. I mean, the students, anybody listening, they go, okay, I get it. Then you've won, right? Then I go home, and tell my wife all about it, and she says, "That's great. Can you go pick up some milk?" My wife's not impressed with my job at all. She's like, "Pick up some milk on your way home." I was like, "All right." There were 2,000 people in the room, babe. Great. pick up some milk. So, Venetia, I'm trying very hard to make it to India. I was supposed to be in India this year, but it didn't come through. But I would love to. Thank you for thank you for that. I appreciate that. Excuse me.
Thank you. And now, in the interest of time, like we would have like take two more questions from audience. Obviously, it's a Saturday, and Eric is very early in the morning. So yeah, let's
Well, I'm
let's.
up now. Let's go.
Yeah, we should have like a full long session, not a shorter one with you, Eric, probably in future.
I'll be glad to.
That would be.
Yeah.
Let me pick up a question from Pawan, and he's obviously thanking you from the answering the last question. Is it correct to say EDA is integral part of serverless?
Yeah, absolutely. And I often say, and I'm sure someone could prove me wrong on this, but not all EDA is serverless, but all serverless is EDA. And so there's some we're starting, and this is where you get into the definition of serverless. And we're guilty of it too. We kind of throw serverless at the name of everything, right? So, but serverless as we understand it, as we define it, or as I define it, as Eric Johnson defines it, is primarily EDA. But yeah, it is integral when we think of, because so let's go back to the very core for a moment, and I do want to be conscious of time, but back to the very core idea. One of the first, Lambda functions weren't the first serverless service, right? You go back early, you go to S3, right? You go to those, but it was the first one to be. Yeah, exactly. Yeah. It was the first one to be kind of called serverless, right? And so we took this idea and said, hey, while you're used to running this box with your code in it and it just sits out there forever, we're going to change that paradigm, and we're going to say, only run it when you need it. It's event driven. And that was, 2014 was like, I remember standing in the room and going, why would you do it any other way? Now, there are some reasons, there's some, where we start with like containers, service containers. We bring those in, longer running, maybe, some different processors, things like that. But that event driven, so back to your question, that event driven idea, why would I do it any other way? When it finally clicked in my head, it was like, yeah, that's a no brainer.
Great. Thank you. Now, I want to ask one question, like, okay, we evolved from physical servers to virtual machine, and then we had containers and then serverless. What is coming next? Can you reveal some futuristic information?
Wow. Well, obviously, see if I can. I'm trying to decide what I can say, what I can't hear. That's the challenge of a DA right there. I remember. I'm going to go back to that question. I remember when I first started going, I'm going to say something. I'm going to blow it. Stuff like that. But I don't know if I see a lot of in the near future the change in compute. And that's what you were talking about, right? In compute, because we've gotten to this, there is no compute in our compute now. There is. So the compute is considered, I think it's these access patterns, right? So Lambda is a really solid ethereal compute solution. And then you roll in these serverless containers. You can say, okay, some workloads I need to do this, some workloads I need to do this, and that makes sense based on, let's say Lambda has a limit of 15 minutes. I need to use serverless container. I can't remember which one was container. I need to use serverless containers, or I need, I don't know, whatever. We can do that another time, but. I think the next thing we're seeing, we're kind of there, but it's going to grow more, is direct integration. The no need for compute. One of the things we found, with compute, especially when we're on, on machines and in virtual and even in containers and even in Lambda, is we find ourselves using compute to route data. You don't need to. Yeah. Compute should only be used. And people ask me, are you anti-Lambda? No, I'm not anti-Lambda. I love Lambda functions. But I think they should be used for the right reasons, and that's to actually do business logic. If it's just routing, then these direct integrations make more sense. And what I mean by that, well, direct integrations is I can talk to API Gateway directly to DynamoDB. I don't have to have a Lambda function there. Now, it's not the easiest thing in the world, but we've done some strides to make it easier. And I have a lot of stuff out there on this, but we're working to make those kind of things easier. And then step functions is a huge game changer in this, right? And the fact that I can do direct integrations with the API. I love I go to step functions as that's where I start all the time, and then I'll roll out to lambdas to do, or lambda function to do compute as needed. So I think that's kind of where we're headed. The other thing I would say, and obviously we're in a, the Gen AI and all that's blowing up, and we have Code Whisperer, which is incredible, and we've got different things coming out. I see it. The primitives, lambdas, step functions, things like that, those are going to continue to change. We're going to add to those, and those are going to keep growing and things like that. But I think that development experience is probably where you're going to see the biggest explosions going forward. There's a couple of, and I'll name two of them, and there's more than two, but Jeremy Daly, call out Jeremy. Jeremy Daly's building a product called Amped. And Amped is this kind of infrastructure from code, and so it's one. You build a single screen. Elad Ben Israel, who actually created the CDK, he's got a company doing this. Both companies they're slightly different approaches in a really cool space where they're saying, look, you build this monolithic app on screen, but it's going to compile to a microservices app. And that's a game changer because developers struggle. I went back earlier. That kind of development experience is tough because it's that mindset change. This helps you do what you know, but take advantage of this EDA and serverless and stuff. So I think those are some of the big changes coming. Hopefully that helps.
Makes sense. Really interesting insight.
Yeah. By the way, Elad, just shout out to Elad as well. His is called Winglang, and Jeremy's is called Amped, AMPT. If you're a developer, check them out. They're both in alpha. So, they're not going to do everything yet, but whoa, just get the idea around. It's really cool. And they both use serverless.
Thank you. And for audience here, we would capture links Eric talked about and put it on a resource page so that you could refer it afterwards. Shouldn't be a problem. So we'll do that. And obviously, Eric, we would like to include your YouTube videos and other details, like any blog posts which you regularly publish, so that people could benefit from it.
Great. If you share a video, if you go on YouTube, you look up Attitude of Iteration. If you enjoy some comedy, but it's a fun message. I do a talk called Attitude of Iteration, and it really is talking about overcoming challenges. A lot of people ask, the hands are obviously better than 5 fingers. They don't say better, but that's how I take it. But my hands are different, and so I talk about what that means, kind of life, and so that's a fun video. It's a lot of life. It's a lot of one-finger jokes, So, but it's fun. So that'd be a fun one to share if you wanted to. And then obviously any of the DA stuff too.
Thank you.
Yeah.
All right, good. So we crossed like 30 minutes now than the expected time, and that was so interesting. And I still don't want to cancel this one, but let's stop this. But
we'll do it again.
Session, we will do it again. Thank you so much, Eric. Thanks, audience, also for asking cool question and interesting question. And I hope that we were able to give a little bit more detail to each of you. Let me add Carl also and thank him again for being here. Thanks, Eric.
Yeah, that was
Thanks,
good stuff.
Carl. It was really, really interesting to see all of you and then understand various aspects of technical thing. There's a developer advocate role. So we will keep on bringing this kind of content to you. And if you like content, please show some love to Carl and Eric. Please post them their details on LinkedIn, say that you heard them and you liked it. So obviously, it would also encourage them to wake up at early morning and be here at BESA. Thank you so much. Thanks, everyone. Have a good one. And we'll talk to you in the next session. Thanks, Carl. Thanks, Eric. Thanks, everyone.
Thanks for having us.
Thank you.